Hello and welcome. Today we're going to be looking at ratios, rates, and proportions as we start our new topic of problem solving and data analysis, the third topic on the SAT math portion. As always, we're going to be going through 5 questions, explaining them and looking at the intricacies of this topic so that you can ace the SAT math portion. If you like these videos and found them informative, please be sure to like and subscribe. And with that, let's get started on our first question. Here it is. A rectangular swimming pool measures 12 feet by 24 feet. A scale drawing of the pool uses a scale of 1 to 24. What is the area of the pool in the scale drawing in square inches? Let's see what we can do here. All right, so our initial area is going to be 12 feet by 24 feet, which if we're going to convert that into inches, we multiply by 12 on each side. Now you have your calculator, so let's get our calculators out. And 12 feet using a calculator is 144 inches. 44 inches. 24 feet is going to be 288 inches, which means that if we're doing a scale drawing of 1 to 24, we divide each of those by 24 to get that of the scale drawing, the dimensions are 6 inches and 12 inches. So the total area of the scale drawing is going to be 72 inches, and that's our answer. Now there is a different way to do this, which still uses the same idea, but it is a bit faster. So you have 12 feet by 24 feet. All right, so just multiply those together. And then for each of those, you have 12 inches to a foot. So you can multiply by 12 inches per foot times 12 inches per foot. And that gives you the whole area in inches. And then you can divide by 24 squared. Because we're looking in square dimensions, we have 2 dimensions, so each of them is going to be divided by 24. So in total, the whole thing is going to be divided by 24 squared. So all I have to do is take my calculator out, 12 times 24 times 12 times 12, divided by 24 squared, and that's going to give me 72 square inches, just as before, and that's our answer. Let's move on to the next question. All right, question number 2, here it is. A stack of 10 flyers on a glossy paper weighs 0.3 ounces. Publisher ships 64 flyers in a box that weighs 0.5 ounces. Shipping costs 98 cents for the first ounce and 21 cents for each additional ounce rounded up to the nearest ounce. How much in dollars does it cost the publisher to ship the box with 64 flyers inside? All right. So the 64 flyers, well, how do we do this question? So 10 flyers is 0.3 ounces, which means that 64 ounces, or 64 flyers, sorry, 64 flyers is going to be 0.3 ounces divided by 10, so it's going to be 0.03 ounces per flyer, and then times 64 flyers to get 1.92 ounces. And then, of course, we have the extra 0.5 ounces of the box that we're shipping this whole thing in. All right. So the net weight of the whole thing, the 1.92 plus the 0.5, is going to be 2.42 ounces. So for the first ounce, it costs 98 cents, or $0.98. And then we're left with 1.42 ounces that still need to be shipped. Each additional ounce rounded up. So 1.42 ounces rounded up is going to be 2 ounces. That's going to be 2 times the 21 cents, which is going to be 42 cents. And we can erase this down here. And when we add this up, we get $1.40 as our answer. So it costs $1.40 to ship those 64 flyers inside, since we had to round up for each additional. So even though we had less than half of the full ounce, and if we were just rounding normally to the nearest ounce, we would have rounded down. They're telling us we have to round up, so 98 cents for the first ounce, and then 21 cents for the other 2 ounces that we're going to get from the 64 flyers and the box. So our answer is going to be 1.40, $1.40. And let's move on to the next question. All right, question 3, here it is. A farmer keeps pigs in 2 triangular pens. Each pen can hold 1 pig for every 2 square yards. Let's write that down. 1 pig per 2 square yards of its area. The ratio of the area of the larger pen to the area of the smaller pen is 6 yards squared to 1 yard squared, and the area of the larger pen is 48 square yards. How many more pigs can the larger pen hold than the smaller pen? Well, if the larger pen has 48 square yards, and the ratio of the area is 6 to 1, then the smaller square yard has 8 square yards. So then this one, since we have 1 pig per 2 square yards, this is going to have 24 pigs. And then the smaller pen is going to have 4 pigs. And the difference here is going to be 20 pigs more that the larger pen can hold than the smaller pen. So our answer is 20 more pigs. Let's move on to the next question. All right, question number 4. Here it is. Joe and Marjorie are both competing in a half marathon. Joe runs the first 8 miles of the race in 1 hour, and Marjorie runs the first 8 miles of the race in 52 minutes. If they maintain these individual rates, how many minutes faster will Marjorie's half marathon finish time be than Joe's? The half marathon is an 18-mile race. So Joe ran the 8 miles. Oh, that's not what I meant. Joe ran the 8 miles in 1 hour, or 60 minutes. And Marjorie ran the 8 miles in 52 minutes. So there's a difference of 8 minutes. So 8 minutes for 8 miles, which means that every single mile, there's going to be a difference of 1 minute, right, if they keep those same speeds. Which means that if for 13 miles, the difference is going to end up being 13 minutes. Because the ratio is 1 minute per mile difference. That's the difference between Joe's rate and Marjorie's rate. That's the difference. So our answer is just going to be 13 minutes then, and we can move on. All right, question number 5. Here it is. For every 3 credits of college courses, Chioma spends 3 hours in class and 8 hours studying each week. What is her total class and study time in hours if she takes 13 credits of college courses for 15 weeks? So for every 3 credits of college courses, well, so, okay, let's see what we can do. So 3 credits, and in 1 week, what happens? Well, she has 3 hours in class and 8 hours studying, so that's going to be 11 hours for 3 credits in a week. So we can multiply those 2 together, right? Because if we have 2 weeks, we're going to make 22 hours. If we have 6 credits, we're going to make 22 hours. So we can essentially say 3 credit weeks, right? So for 3 credit weeks, we have 11 hours. Now, how many are they asking for? They have 13 credits. 13 credits. Oops, 13 credits. Credits. And 15 hours, or 15 weeks. We can multiply those two together and we get basically 195 credit weeks, CW. So essentially, we have 195, right? So we have 195. We could say that we had like 195 credits for 1 week, or we could say that we had 1 credit for 195 weeks. Right? It would be the same either way. So if 3 credit weeks is 11 hours, so then 195 credit weeks, which is the 3 credit weeks times 65, is going to be 11 hours times 65, or that's going to be 715 hours. And that's our answer, 715. All right, so as you can see, for this topic, the main idea is just being able to convert between different units to be able to understand when different units mean different things and how to set up ratios, set up proportions, and extrapolate them to different situations. So that's all it really is. It's just connecting two values and then using that connection to find other values, right? It's a basic skill, and that is all that is in this topic. I'll see you next time.